I think my favorite IoT anecdote now is the casino that was hacked via their fish tank. So that's like, wonderful. This talk, I know it's the end of the day and all of that, but this talk, the quick summary is that the stuff that we've learned in communications in general and voice over IP in particular is directly applicable to IoT. Previous speakers have just said that it's a form, these IoT devices are a form of communication, and I'm just saying that the lessons we've learned over the last 10 plus years, particularly in the VoIP space, are directly applicable, and that's actually the core of the message. The reason I kind of got into this is, turns out, I was thinking about writing this talk, and I came to the conclusion that I got into this because I did a Y2K project, so that's 1998, 1999, which was, now thinking about it, was actually a 2FA app. It was a second factor authentication for security for the field service engineers for a financial information company who were going out, rolling out the Y2K fixes, and they needed a second factor authentication on their devices. So I built this thing, and at that point there was pretty much no VoIP, no computer telephony, or minimal computer telephony. And so I learned all about that, and I learned about security kind of all in one project. And then roughly the next 17, 18 years of my life have been driven by the experiences of that. I ended up doing a web security startup almost immediately after that, which actually got sold last year to Capita, so did all right. And I got sidetracked into voice over IP, and I did another startup in that space which got sold to somebody I'm not allowed to mention in this context because they're a competitor, but it ended up in Cisco's hands. This whole thing turned out that way, and then a couple of years ago I got out of that, and I thought, well, spent some time in the webRTC space, helping standardization of that, and kind of got a little bit bored with that because it's almost done. I mean, there's still a lot to do, and in fact, Jeff said to me in Dublin, he said, what are you doing getting out of webRTC? It's just starting. So, yeah, maybe. Anyway, so I figured that actually this was a nice place to be. IoT was a good place to be because it's being done so badly by so many people. And for anyone who thinks that the Germans don't have a sense of humor, this is actually a German joke, which is the S in IoT stands for security, which is actually a pretty decent joke, to be fair. And it's literally true. I mean, it's a fair criticism. I mean, when you start to get a botnet of web cameras taking down the East Coast's internet, then you know that actually you've got a realistic problem. And that's bad, that's embarrassing, that's a PR disaster, but they had to recall them, and that's money. So there's a quantitative difference between things that are like embarrassing and then things that, that actually result in you having to pay money to have things recalled. And that's now starting to happen. We've now had, I think, our second C-level executive fired for this kind of stuff. So it's important matter now. So the thing was that when I looked at this, the whole IoT landscape looked dreadfully familiar, right? I thought about it, and I thought, actually, this is very like my first Zixel VoIP phone. Right, this thing, I'm not quite sure when I got it. It was probably about 2003. It was a Wi-Fi phone that ran SIP very badly. It was a dreadful thing. You could either have a decent codec or you could have encrypted Wi-Fi, but not both. Like limited capability. But when you think about it, like minimal GUI, like a tiny screen, minimal keyboard, a couple of sensors, and it improved on an existing thing by going over the internet. This is like this classic IoT space. And actually, it has a lot of the same problems. And you ask yourself, or I asked myself a couple of years ago, are some of the solutions applicable as well? And then I thought, well, maybe we'll have a look and see if like 10 years of our knowledge in the VoIP space is going to waste in the IoT space. And yeah, obviously the answer is yes. Otherwise I wouldn't be standing here. But you might not believe me. So on the left, you've got the configuration dialog for the Zixel VoIP phone. And that's hideous. And then they tried to render that onto the small screen as well, which is even worse. And there, on the right, you have the Honeywell Wi-Fi thermostat, where you're expected to type in the MAC ID. Like, I'm sorry, there are no circumstances under which that's acceptable. And other lessons, like our friend here, this is a VoIP example on the left with our friend here, Bob Foreman, had the classic VoIP experience of getting into his architecture office one Monday morning and finding out that his PBX had run up a $166,000 bill over the weekend because somebody had hacked it. We do things better in the IoT space. This is an interactive map of all of the hackable yachts. So there's an upmarket satellite communication system that's exclusively targeted at upmarket yachts that has a wide open admin interface that's available over IP. And so you could, and it tells you, this admin interface tells you exactly where the yacht is. Like, I mean, anyway, yeah. And if you think that finding the IP address is going to be difficult, we know from the VoIP space that isn't true, because you know the friendly scanner from SIP Vicious will find your SIP server within, what is it, 10 minutes now of going live on the internet. Somebody will find it. Well, the same's true for IoT, but actually it's even better because there's a site called Shodan, shodan.io, which has a database of all of the IP addresses it scanned and the interfaces it found on them. And it does one better, it takes snapshots of the web interfaces it finds and all the VNC interfaces it finds. And it puts them all in a database, and it's searchable. So you can search for, you know, cameras or whatever, but this one, I actually don't know what that is. I think it's a grain loader, but it could be a luggage carousel. I've no idea. But what you can't see on that is that it has stop and go buttons on an unsecure web interface, right? So, like, you know, this stuff is out there. And okay, it could be a training simulator, but I don't think it is. And then there's this thing, like we knew this in the VoIP space, that actually for the perceived quality of getting the latency down hugely improved your perceived quality of the call. And the same turns out to be true for light switches. It's just like, you couldn't live with it. Well, I couldn't live with a light switch that took that long to come on. Oh yeah, and this is the fish tank story. There's a quote on the guy who reviewed, so going back to the light switches, the guy who reviewed the light switches, he said it's amazing how much you yearn for a simple switch when it takes you 2 seconds to switch the lights on. And that tells you that we're doing it wrong, okay? Yeah, this turns out, I think, to be true. Like, you wouldn't want to believe it, but and it's in Forbes, so it's probably true. And it turns out that this thing was on the internet and to monitor the temperature of the fish. That isn't actually the right fish tank. But so the story here is that we kind of learned all this stuff in the VoIP space. And to be, in my view, and I'm biased because I was part of the standards effort for it, but in my view, webRTC absorbed the majority of these lessons and took them to heart. So in a sense, webRTC is the kind of the output of these lessons that we had in the VoIP space. You know, it's at least as secure as the web browser you're sitting in. That's the target. You need low latency, otherwise it's unacceptable. You need transport security, and in fact, webRTC's got really good transport security. I mean, DTLS SRTP is a good choice. It does perfect forward secrecy. You know, it's a good platform. And they've minimized the attack surface, so like the ports aren't open by default. They have to be open specifically, and they can monitor what's coming in, and they block things that haven't had ICE permissions. And above all that, webRTC is using standard understood protocols like DTLS and standard crypto. It's not making up new stuff. It's kind of assembling layers of new layerings, but it's essentially all done stuff. So that means that it's been looked at by researchers. Now the IoT goals, or my goals for IoT, was to be at least as secure as pretty much anybody else's IoT. To be as easy to use. Now the thing is, if you don't have easy to use security, people will find a way past it. Right? If the security gets in the way, then people will just like avoid it and they'll write passwords on the wall or whatever. We want identity management. We want good identity management. Now I'm specifically interested in consumer IoT, which is slightly distinct from bins and bin lorries. Although I do have a question, a niggle with the previous speaker who was saying that you need a super low power device on a garbage truck. It's not true. There's things putting out kilowatts. You can put a small Linux machine on there and not notice it as far as the load's concerned. Now there might be other reasons why you want to put a small device in your bin, for example, but for the truck that ain't true, in my view. Yeah, you want to minimize the attack surface for all the reasons you've just seen, and you want to use standard crypto. So it's a kind of reasonable match, with the exception of the identity management, which is webRTC kind of veers away from, which is where Pipe comes in. Pipe is what I've been doing for the last couple of years, and it's basically around the idea that you can use webRTC as a channel for IoT traffic. And the nice thing, the nice properties that you get out of that is, you've got standards-based cryptography in WebRTC that you can then repurpose into IoT. You've got a zero installed client in all of the major browsers, and that's like 2.5 billion of them or whatever it is now out there. Well, the trick we've added is to how we do identity management and how we do onboarding, and that's using X509s, but using them in a nice way. And then we do verification that you are the owner of the device, and this works better in consumer space than it does in enterprise, using a QR code or a Bluetooth LE signal. Now, I did the first prototype of this, and I showed it to a friend of mine, and he said, "That looks like the Duckling protocol." And I said, "What?" He said, "Well, it's a Ross Anderson paper from the 90s, and he was a student in Cambridge in the 90s, so he knew this. And so Ross Anderson's a prof of computer science at Cambridge, and he wrote this paper, which is called something like The Resurrected Duckling. And it's about the idea that an IoT device will trust the first thing that it sees. When you first power it on, it will be like a duckling, allegedly. When it first sees it, it will think that's its mother. I'm not sure if this is actually anthropomorphically true, but whatever. So the point being that if you're in proximity with the device when you first switch it on, then you can prove that you own it. That's treated as proof of ownership. Now, we actually turn this around because we have the device, in most cases we have the device showing a QR code. And then the smartphone scans that and uses that QR code as an address, but it also uses it to verify the certificate. And then effectively the first to connect on power up gets to own it, provided they can prove that they were close to it. So in deference to the fact that I had a series of complicated internet disasters this morning, I'm going to show this as a video now to preserve the demo environment for the demo I want to do at the end. So there will be a demo, but it's not yet. So we'll make this full screen. I'm the CTO of Pipe. So I'm going to show you how Pipe can be used to pair a IoT device with a smartphone. So what we have here is a IoT device that runs the Pipe code. And what happens is that when you first get a device like that, and you first power it on, it shows you a QR code, which allows you to claim that device using a web browser. So in the web browser here on my smartphone, on my Android phone, I'm going to go to the claim page and then show it this QR code. Now the two of them now exchange cryptographic keys, and they now recognize each other. They have done a key exchange. Now I just want to emphasize, that's a full provisioning. That is that device provisioned to my phone. That was it. 2.5 seconds or whatever it was. Full set of X509s exchanged. It doesn't care about the networking. The networking, provided they both IP connected, it will work its way out, because that's what WebRTC does.
and they recognize each other, and that's not through a third-party authentication service, and you'll notice there are no passwords used. It's simply that I was in proximity with the device when I first switched it on, and that I could therefore read the QR code. So now we have these two recognizing each other in a cryptographically strong way, and through a protocol that will find its way through the internet. So this device is on 4G and that's on Wi-Fi, and now I can look at, say, the CPU temperature on that device. So I go to the correct page on my website and browse, select the device that I want to monitor the temperature of, and there we go, we get the reading. Now, what's nice about this is that, as I said, it forms a secure connection. And
okay, you got the message, I hope. So the other thing you can do with that then is to do lend and borrow, which is kind of interesting. So you can then extend that trust. So I now own this washing machine, temperature sensor, whatever it is. I claimed ownership of it. It recognizes me. I can then lend it to somebody else who's in the house by taking their X509 public key through into my device and then pushing it down onto the washing machine and saying, hey, trust this public key. So you're kind of building a miniature PKI of your own stuff on your own network with the authentication local to the device. It's kind of different. It's a different way of thinking than the, hey, we'll do it all in the cloud thing. And we've also tried to extend the different way of thinking out into the webcam side. So if you're using this as a webcam, this is what the code would look like for writing a webcam in JavaScript. And it's basically you just open a correctly named channel and the device will do the right thing with that channel. I shamelessly stole that idea from Plan 9. I don't know if any of you remember Plan 9, probably not, you're all too young. Plan 9 was the thing that the Unix inventors did when they got pissed off with Unix getting serious. And they built this thing called Plan 9, deliberately called Plan 9 because they knew that nobody could commercialize something with a daft name like that was named after a dreadful horror film. But it had this core concept that everything was a file. Everything. Your screen was a file, your keyboard was a file, everything was a file. I mean, kind of, Linux does that to an extent, but Plan 9 took it way further, because you could export all of these things over file system exporting. Anyway, so that's what it looks like on the JavaScript end, and then on the other end of a device, what you might have is a Raspberry Pi or something of that ilk. So we're talking $7 or $8. Or maybe more. I mean, the chip also is cheap. So we're not talking seriously expensive hardware at that end, but we're not talking totally trivial. We want a Linux on that end. And we've got a little lightweight WebRTC stack of our own to run on those devices that knows it's not in a browser and makes a whole load of shortcuts based on that. And then all you have to do to provision that up is, or if you're a device manufacturer, is provide a script that will generate, in this case, MJPEGs or H.264 if you want it that way. Now, this is the bit where things get really deeply scary. First thing, I should warn so what we're going to try, what I'm going to attempt to do, which I think it's pretty close to a lost cause, but it's like worth a shot because it's that time of day and we really should. So first things first, what I'm going to try and do is I'm going to try and get my friend in Berlin to drive, co-worker, to drive a drone around the stage in here. So the chances of this working are, I freely admit, slim, but it's worth a shot. So, and by the way, this is a BeagleBone, which is like a Raspberry Pi, only it's American. And it has a couple of nice properties. But this BeagleBone has on it a Texas Instruments digital light projector, which is basically a beamer. It's a little beamer, but it sits on top of the board. And their market for it it's great, actually. It's a lovely thing. I mean, I bought it purely because it's a beautiful thing. Ooh, that's not looking good. their market for it is to down project onto ceramic cookers. So you can project them, so you can use this thing on anywhere where you couldn't realistically put a glass screen. You can project onto a hot tank, something that isn't flat, anywhere where you don't think. I should have warned her. Yeah, great. So she's going to be furious. Let's see if I can get this in focus. One of the design flaws is that the focus on this is rubbish. There we go. But right, so that's the Beagle bone. We've got our connection. What else do I need to do? Something else, something really scary. What was it? Oh yeah, I know. Turn the drone on. Oh yeah, the other thing that we've done with this, because I got bored with trying to remember how to log into these things, I built a little thing in the browser that uses pipe authentication to log me into log me into a webRTC device and give me a little terminal window. So now what we need to do is just check that it's... So this is a terminal onto the Beagle bone over webRTC, because I can. Yes, it does. Oh. It does exist. Don't lie to me. Yeah, it's got a proximity sensor on it, which has been driving me mad all day. All right, so now we'll just see if we can connect to the drone. So in theory, I mean, in the ideal situation, this drone would be connected, this code would be running not on the Beagle bone, but in the drone. But I didn't want to brick it, so it's running in the drone. Right, now, what we're going to do is we're going to make a video call to Birgit in Berlin, and if she hasn't got thoroughly pissed off with me, she should answer. Not looking good. Hey, sorry about not warning you.
Hello.
You're live on a huge screen.
Hello.
So, can you do a screen share? And I think everything's set up for you to drive it. I might be wrong, but that's the plan anyway.
Well, that's my screen.
So this is just a web page of a Chrome browser running in Berlin. You don't need to borrow. We can just do drive. We'll keep the. We did the lend. So yeah, you pick the one with the shadow on it. That's the one. And this is where we find that nothing works. Well, that's a surprisingly good sign. Try driving it. See what happens.
Well, let's.
Yes. Now,
I don't
you don't have any image though. We do, but if you dim the lights, you'll be able to see what we're doing. But you don't have. Your image hasn't shown up.
Yeah. That's true.
Do you want to quit that and just? If you quit that, wait about 30 seconds and then reconnect. It might come back. Give it a second. Wait. That sighing noise means that it's disconnected. So, no, really. Okay, try again. And what I'm going to do is I'm going to kill my video feed because I think I'm sucking all the bandwidth.
Yeah.
Okay, try that.
I'm clicking on it.
Yeah, go for it.
So let's see, it's probably loading.
Oh, come on. So close. Good, yeah, one more reload, go on. Let's just try it one more time. Actual shift reload, clear everything in case it's... Yeah, go on. This is going to work this time.
Okay. I'm clicking on it.
Yeah. All right. I'm going to reboot the drone just on the off chance that it's sulking. Give me a second.
Yes, I was the first time.
If you reload that page, and I'll reboot the drone, and we'll be in a clean start. And I've turned my video off, so we've got a chance at least. It's one of those things where we tested it last night and it worked perfectly, but of course tested it this morning and it didn't. So.
Picture or it didn't happen.
So if you reload now, but don't click yet because it's still booting up.
Okay.
All right, now I need to. Hang on, I just need to check it's come back on the Wi-Fi, which it probably hasn't. No, I'm not even getting a local connection now. Something's gone wrong. No, this is annoying.
What happened?
I can't talk to it locally either. I can't talk to the BeagleBone locally. It's not talking to me. No. Now I'm pissed off. Right, well, I'm going to abandon this in a minute. I'm just going to do a clean reboot of everything and then I'm going to give up. I fear we have some internet gremlins, which we had earlier as well. But anyway, it did drive. She did drive it. It's just like...
Yes.
Hang on. Right, I'm going to talk for a little while this is rebooting. The thesis here is which I've inadequately proven by trying to do too much in one thing, is that you can use webRTC to create a low latency video link between here and Germany onto an IoT device. And given how slowly that's loading, I think, well, that ought to be all right, actually. Let's see if I can talk to it now. You see, that was, yeah.
So it's basically the drone, not pipe.
Yeah, it's a bit of both, I think, actually. A bit of both, unfortunately. Right, go on, give it one more try, and then we're going to give up.
I'm going to drive sumo.
Yeah.
And then I click on it.
Uh-huh. Well, that's a good start.
Yeah.
Wait. Now try driving. You're moving, but you haven't got any video. Well, just turn left a bit. We're going to do like Bernie the Bolt. Turn left a bit, straight forwards. I'm really frustrated by this. Keep going, you've got a long way to go forwards. Keep going forwards. Keep going forwards. Oh, you're stuck now. I'm going to put you in the... Wait a minute. I'm going to put you on the aisle and make you run. If you just go straight forwards as far as you can go. Straight forwards. Just hold the forwards button until it... Well, if it goes under your chair, I'd ask you to rescue it. It won't bite. So the frustrating thing is, actually, can you dim the lights a second? Because you can see what it can see here on this screen, but unfortunately it's not making its way to Germany and back.
Yeah. Oh!
So wherever it is, if you could pick it up and turn it around. Oh, turn it around, actually. Turn it around and come back. You're at the far end somewhere. Actually, I don't know where you are.
So
this is this is huge. It's a huge lag on this. So we're anyway. I think we've proved something, but not quite what I wanted to prove. Hey, Birgit, thank you so much for doing that. I appreciate your willingness to take part in this foolishness. So, not quite what I'd hoped for, but it'll do. Right, so, my point, the serious point, I mean, forgiving all the clowning, the serious point is that a lot of the lessons that we learned in VoIP over 10 plus years are actually directly applicable to VoIP, to IoT, and that you guys who maybe have some of that experience, you might want to think about repurposing some of that into your portfolio of either skills or investment or consulting or whatever, or as a service provider, into the IoT space. Because, I mean, that's what Twilio are doing. And I think, in particular, I think the data channel is really interesting as a way of bridging those two worlds. And the final point, which I want to leave as a kind of little thought for you, is IVR, right? A lot of you probably have experience of IVR. Ask yourself, how are you going to communicate with the user of a smart doorbell? Right? And the answer is you're going to put them through an IVR session effectively. You're going to say, press 7 to reconfigure it, press 5 to... But the doorbell's going to say it rather than the phone. It's a lot of the skills that we've got in this space that we've built up over the years are repurposable. And I want to thank you hugely for putting up with my foolishness, but it's the end of the day. Thank you.